Welcome to Handson with Jota. We're going to take a look into tail recursion and head recursion. So these are concepts that comes from functional programming, and they actually come from very well-known language out there for functional programming, which is called Haskell. In Haskell was one of the main features of Haskell was working with infinite lists. So basically, when you have an infinite list, you want to go item through item, and you can go from the head or you can go from the tail, and you don't know how many items you have there. So let's go for it. Let's take a look into an example, but this is going to be with a finite list, which is going to be just with a simple array. Let's say, for example, like this, and then we're going to say function tail recursion, which is going to receive a list and an index, and then we're going to say console log of the list in a certain index, and from here we're going to say if index equals 0, then we're going to say done, and then we're going to return. So basically what happens in many cases also in Haskell is that you're going to have an initial situation, and you're going to have also the recursive situation, we can say. So here you're going to say tailrecursion. So I'm calling to myself to the same function, we can say, with the list and the index minus minus. So I'm going to remove this from here. Okay. And here we're going to say so here what I'm thinking right now is how is it going to be iterating through. So as you can see, the very beginning of everything is going to say, okay, the index is equal to 0, so this is going to be the last situation, right? Because we're going to from the head to the tail, right? So we're going to go from 4, 3, 2, 1, and these are going to be the indexes that come from here. When the index is equal to 0, I want to print it out, and then I want to say done. When the index is not equal to 0, I want to make the print of this result. And the actually is going to be first I'm going to assign the index. I'm going to say that the index is equals to the index or the list.length minus 1. The reason is the following. In this case, for example, the length is equal to 4 values, right? The arrays are 0 based, so the last value is going to be 4, but for the length, but for the array itself is going to be the third position is going to be from 0 to 3, so it's going to be length minus 1. Here I'm going to be saying list index, which is going to be, in this case, at first glance, is going to be 3. Then we go to the recursion with the number 3, with the same list, comes back, makes the index is equal to 0, no, then we continue. We have an index value, and that index value is going to be 3. No, I'm sorry, this is going to be 3. So we need to do like that, because we need to evaluate the index minus 1 before. Okay, let's go again. So once and again, go to the recursion. Index of 0, we print it out, and this is the last situation. The index is going to be equal to the index or the list.length minus 1. Then we print out the list index. In this case, it's going to be 3, so it's going to go and print 4. Let's go to the next situation. We pass the list, and the index minus 1 value. So get back here. The index in this case is going to be the number 2. So it's going to be the number 3 here. It exists in this 2, and then it's going to say console log of the list index. We go to next value, and so on, so on, so on. So we get to the number 0, and the 0 says, let's print it out, let's say done, and let's finish. This should work. So there we are, 4, 3, 2, 1, done. That's the third recursion. So basically, we are going to from the last value to the front, right? So you can do exactly the same, but with the head recursion. So if you say head recursion list index, and you can say if index console of the index and we return. So otherwise we can say the following. We can say index but we start from 0. If it comes, perfect. Otherwise we go for 0. We print it out. Of the list in the index minus, but in this case it's not it's not index minus 1, it's plus plus, because we're going ahead. So this is exactly the same logic as before, but with small differences. We're going to go through this list of A that comes with 1, 2, 3, 4, but we're going to say, okay, first we print the 0, which is this one case, right? And then we go for the next value of the index, which is going to be 1. So 1 is not equal to list.length minus 1, which is the next case. So 2, and then 3. And when it is 3, it's going to say, okay, 3 is equal to list.length minus 1. Then we're going to print out the list index, and then we're going to say done, and we're going to finish, right? It should work too. Of A, 1, 2, 3, 4, and done. So you see, this is the tail recursion and the head recursion. You're going from the tail or from the head, and you're going to be looking into each one of these different values, and you are going to be able to iterate through each one of them without knowing that much of how much is the length of these values, right? This is the use case for what is going to be actually there are different kind of use cases for this. It's not very common that you're going to be iterating with tail recursion and head recursion unless you're going to be working with specific use cases, like saying trees. For example, when you want to iterate through a binary tree, or you want to iterate through a certain kind of tree, you're going to be using some of these kind of tools like head recursion, tail recursion. But the reason for this is that you have a decision maker here for each one of the different values that you're going to be iterating through, and you can go to a left side of the tree or the right side of the tree, considering your own decisions. So this kind of recursion, where you're going to be making a self recursion there, is going to be taking into account a conjunction of different values, and you're going to be considering where you go inside of the tree. This is one of the use cases. The second another use case is that is in another language which is C or C++ in some cases, is that when you iterate through certain values, considering a for loop or a while loop, these operations are considered blocking for some languages like C or C++. Saying this, the head recursion and the tail recursion is going to be working with himself once and again, and this kind of things is going to be calling to is going to go to the call stack. It's going to go to each one of these different parts of the process, but it's going to get back the processing to the user, we can say at some point, right? So this is not blocking, so which is different situation than the for loop and the while loop. This is for this kind of languages. The other case is when you know how many different values are going to have in a certain iteration through. So you need to go and iterate through each one of these different situations and have full control of how you iterate through that, and say, okay, up to here I want to do this, otherwise do something else. So very specific use cases for this kind of guys, right? I mean, it's not very common that you're going to be doing this, and I think that nowadays JavaScript offers a lot of different options in regards to how to iterate through certain values, a certain collection of values. But this is just one more option that's out there, and this is actually something that comes out of the box with the language itself. It's something that comes from a long time ago, comes from languages like Haskell, Lisp. You are going to be able to work with these kind of things like iterating through, right, from the head recursion of the tail recursion. I hope that you like the video of today. Till next time, if you like it, just click with like and subscribe to the channel. We're going to see a lot of different techniques out there, right?